Hey everybody, here's another example video to help you out with this next Jamboard assignment that you'll be working on today and tomorrow. In this one, we're going to start solving equations, as in determining what value of x makes the equation true, using that strategy we learned yesterday called completing the square. So this time it's not just the expression here, we have it set equal to 0. Important thing with completing the square is it has to be equal to 0 over here in order for it to really work effectively for us. So we're going to follow that new strategy, completing the square. Let's set up our diagram to represent what our equation is here. We have x squared, so that's just a nice perfect square like this. X by x makes this area x squared, and then we'll have 6x. We'll make those 6 different rectangles. So we have 1x, and we'll make 6 of them. 1, 2, 3, 4, 5, and 6. All right, so I'm going to divide these up. I'm going to put 3 of them up here. So divided in half, 3 divided by 2, or 6 divided by 2 makes 3. And then I'll put 3 on their sides down here. All right, and then I had 5 unit squares. So those are just 5 small squares. There's 1. And then I'll make 4 more. 2, 3, 4, and 5. Piece those in. Doesn't have to be perfect as long as we get the idea here. And it looks like we are short 1, 2, 3, 4 squares. So I'll make 4 red squares to fit in there to represent the 4 that we're short. 1, 2, 3, and 4. Piece these in. And here's our diagram. So this diagram completely as a sum of all of its pieces is x squared plus 6x's plus, well, 9 squares. Sure, there are 4 that really aren't there. So we can rewrite this now as x squared plus 6x plus 9. But there are 4 that aren't really here, 4 missing, so we're going to subtract 4. And this should make sense because 9 minus 4 gets us back to this 5 right here. So always check that. 9 minus 4 is 5. All right, we're good. And this is still set equal to 0. All right, the other way we can think of this, though, is as a product of its dimensions. So we have x, and then 1, 2, 3, x, and then 1, 2, 3. These are positive ones right here. So x plus 3 over here, and x plus 3 up here. So this is just x plus 3 squared. Because when I find the area of the whole thing, it's x plus 3 times x plus 3. It's x plus 3 squared. And then we still have this pesky minus 4 right here. And it's still set equal to 0. All right, and now we can go through and solve this a little more. Done with the diagram, I'm going to zoom in right here. All right, so our goal now, we've solved equations like this in the past, is to isolate x. Well, first we want to get rid of this minus 4. It's outside of this quantity right here, so let's add 4 to both sides. I'll have x plus 3 squared minus 4 still. And then I'm going to add a 4 to both sides of the equation. So a plus 4 right here. And then we'll have equals 0 plus 4 as well. So the new equation is now x plus 3 squared is equal to positive 4. Because negative 4 plus 4 is 0, and 0 plus 4 is 4. Okay, if we flash back now, we can think, well, how can we cancel out a square? Well, we know the opposite of a square, the inverse of a square, is a square root. So what we can do is just take the square root of both sides of the equation. But the thing is, when we take the square root of both sides, we know that there's going to be two square roots over here, a positive square root and a negative square root. So we'll have the square root there, positive square root, or the negative square root. So what we have is x plus 3 squared is equal to the positive square root of 4 or the negative square root of 4. All right, and let's split this up. So we're going to have, well, the square root of x plus 3 squared is just x plus 3. And that's going to equal the square root of 4, which is 2. Or our other option is that this x plus 3 squared being square rooted, again, that's x plus 3, is equal to negative square root of 4, which is negative 2. And now we're pretty much done. X plus 3 equals 2. Well, what would x have to be equal to here? Well, negative 1. We could subtract 3 from both sides if we wanted, but it should make sense that negative 1 works here because negative 1 plus 3 is 2. Or, over here, x plus 3 equals negative 2. Well, in order for that to be true, we could subtract 3 from both sides, or we can just think negative 5 plus 3 is negative 2. So x equals negative 5. And we have our solutions. X is equal to negative 1, or x is equal to negative 5. And there's an example to help you out with how to complete the square in order to solve an equation. All right, good luck. Have fun.